And I thought we could have the model play a little game where it first generates a puzzle to solve, then we ask another instance of the model to try to solve the problem that it generated. So yeah, I'll ask it, generate, say, a 5x5 nonogram where the final answer is the letter M. We'll see what it comes up with. All right, we see it just gave us a little puzzle. We'll go ahead and copy this, open up another window of O1, ask it solve the following puzzle, and let's say visualize the answer in some pretty way. Why not? This puzzle doesn't look like it's too hard, but the way that a nonogram works is for each row and each column, you're given a list of numbers, and the numbers tell you how many squares are filled in. And if the squares are consecutive, then you'll see like a 2 for 2 consecutive squares. If there's a space between them, you'll see a 1, 1. And so you're supposed to just try to figure out which squares do I indeed have to fill in. And it looks like the model got this right. Illustrated a nice little letter M. But I think one of the things that is like nice about examples like this is it's similar to like Sudoku or a crossword, for example, where you have to kind of make a guess and then see if that's a right guess or a wrong guess, and then backtrack if you get it wrong. And so any type of task where you kind of have to search through a space where you have different pieces pointing in different directions, but there are mutual dependencies, so you might get a bit of information that tells you that these two pieces contradict each other. Like a model like O1 is really good at trying to refine the search space here.
OpenAI has introduced the much-awaited strawberry model we have all been waiting for. OpenAI O1 is a new large language model trained with reinforcement learning to perform complex reasoning. O1 thinks before it answers. It can produce a long internal chain of thought before responding to the user. The rumors were that it would take long to answer questions because it first had to think before giving out the answer. Now that it has been released, what is it like, and what sort of tasks will it be used for? They claim that OpenAI O1 ranks in the 89th percentile on competitive programming questions, placing among the top 500 students in the U.S. in a qualifier for the USA Math Olympiad, AIME. It also exceeds human PhD-level accuracy on a benchmark of physics, biology, and chemistry problems, GPQA. While the work needed to make this new model as easy to use as current models is still ongoing, we are releasing an early version of this model, OpenAI O1 Preview, for immediate use in ChatGPT and to trusted API users. They also claim that their large-scale reinforcement learning algorithm teaches the model how to think productively using its chain of thought in a highly data-efficient training process. They have found that the performance of O1 consistently improves with more reinforcement learning, train time compute, and with more time spent thinking, test time compute. The constraints on scaling this approach differ substantially from those of LLM pre-training, and they are continuing to investigate them. Before we look at the graphs and the evals they have offered us, let us first watch a short demo they released on coding.
So I just typed in this command and see how the model does. So unlike the previous models like GPT-4o, it will think before outputting an answer. So it started thinking. As it's thinking, let me show you what are some of these requirements. I'm giving a bunch of requirements to think through. So first one is like, use an example sentence, the quick brown fox. And second one is like, when hovering over a token, visualize the edges whose thicknesses are proportional to the attention score. And that means just if the two words are more relevant, then have a thicker edges and so on. So the one common failure in most of the existing models is that when you give a lot of the instructions to follow, it can miss one of them. Just like humans can miss one of them if you give too many of them at once. So because this reasoning model can think very slowly and carefully, it can go through each requirement in depth, and that reduces the chance of missing the instruction. So this output code, let me copy paste this into a terminal. So I'm going to use the editor of 2024. So Vim HTML. So I'm just going to paste this thing into that and just save it out. And on the browser, I'll just try to open this up. And you can see that when I hover over this thing, it shows the arrows, and then quick and brown and so on. And when I hover out of it, it goes away. So that's a correctly rendered version of it. Now when I click on it, it shows the attention scores as just as I asked for. And maybe there's a little bit of rendering, like it's overlapping, but other than that, it's actually much better than what I could have done. Yeah, so this model did really nicely. I think this can be a really useful tool for me to come up with a bunch of different visualization tools for my new teaching sessions.
So the first video you watched was a math test, and this one was a coding video. At a glance, one may not see any improvement from what Claude 3.5 Sonnet can do, but let us look at the beautiful graphs they always give us. OpenAI claims that the graphs you can see on the screen were to test the reasoning abilities of the model, and you can see how it dwarfs GPT-4o in the math and code benchmarks and outperforms humans in PhD-level sciences. O1 improves over GPT-4o on a wide range of benchmarks, including 54 out of 57 MMLU subcategories. Remember to not always take these benchmarks seriously, because most of them have been corrupted. Most of them have already been leaked, and at times the models may be overfitting in some of the benchmarks. Similar to how a human may think for a long time before responding to a difficult question, O1 uses a chain of thought when attempting to solve a problem. Through reinforcement learning, O1 learns to hone its chain of thought and refine the strategies it uses. It learns to recognize and correct its mistakes. It learns to break down tricky steps into simpler ones. It learns to try a different approach when the current one isn't working. This process dramatically improves the model's ability to reason. COD has been a known technique for a while now, and it was always believed to improve the model's ability because it would reflect on the answer that it is to give and improve on it before answering. The model scored 213 points and ranked in the 49th percentile in the 2024 International Olympiad in Informatics by initializing from O1 and training to further improve programming skills. This model competed in the 2024 IOI under the same conditions as the human contestants. It had 10 hours to solve 6 challenging algorithmic problems and was allowed 50 submissions per problem. They also simulated competitive programming contests hosted by Codeforces to demonstrate this model's coding skill. Their evaluations closely matched competition rules and allowed for 10 submissions. GPT-4o achieved an yellow rating of 808, which is in the 11th percentile of human competitors. This model far exceeded both GPT-4o and O1. It achieved a rating of 1807, performing better than 93% of competitors. The O1 they're talking about here that was defeated was a base model and not fine-tuned on coding. In addition to exams and academic benchmarks, they also evaluated human preference of O1 preview versus GPT-4o on challenging, open-ended prompts in a broad spectrum of domains. In this evaluation, human trainers were shown anonymized responses to a prompt from O1, Preview, and GPT-4o and voted for which response they preferred. O1 Preview is preferred to GPT-4o by a large margin in reasoning-heavy categories like data analysis, coding, and math. However, O1 Preview is not preferred on some natural language tasks, suggesting that it is not well-suited for all use cases. The graph suggests that maths and coding were the first choice for most people. But I wonder how it would compete with Claude 3.5, which is the favorite for many people. Safety is another area they touched on, and it appears that chain of thought reasoning offers new approaches to tackle the alignment problem. They found that integrating their policies for model behavior into the chain of thought of a reasoning model is an effective way to teach human values and principles. By teaching the model safety rules and how to reason about them in context, they found evidence of reasoning capability directly benefiting model robustness. O1 Preview achieved substantially improved performance on key jailbreak evaluations and their hardest internal benchmarks for evaluating the model's safety refusal boundaries. They believe that using a chain of thought offers significant advances for safety and alignment because 1. It enables them to observe the model thinking in a legible way, and 2. The model reasoning about safety rules is more robust to out-of-distribution scenarios. Safety is a key thing that you will see from all AI companies because we need safe AGI. The more advanced the models get, the more safety measures will be added to them to prevent the potential for misuse or going rogue if it is possible. But here's an interesting thing about hiding the chain of thought reasoning process from the user. Assuming it is faithful and legible, the hidden chain of thought allows us to read the mind of the model and understand its thought process. For example, in the future, we may wish to monitor the chain of thought for signs of manipulating the user. However, for this to work, the model must have freedom to express its thoughts in an unaltered form, so we cannot train any policy compliance or user preferences onto the chain of thought. We also do not want to make an unaligned chain of thought directly visible to users. Therefore, after weighing multiple factors including user experience, competitive advantage, and the option to pursue the chain of thought monitoring, we have decided not to show the raw chains of thought to users. We acknowledge this decision has disadvantages. We strive to partially make up for it by teaching the model to reproduce any useful ideas from the chain of thought in the answer. For the O1 model series, we show a model-generated summary of the chain of thought. What do you think about them hiding COD from the users? Is this to safeguard the model or to prevent reverse engineering of the model? Let me know in the comments below.